Hello and welcome to the UVB Lab 3 video. Our team consists of Nicolette Madonna, myself, Harry Labampa, Nazim Camille, Jordan Sun, and Tim Engel. Our UN SDG is UN SDG 12, specifically focusing on sustainable production patterns and goal 2.4 and 2.5, reducing the use of harmful chemicals and contamination of the environment by them. Our goal is to contribute to the significant reductions of chemical by 2030 via alternative methods. Our group plans to use UVB light as a substitute for chemical pesticides and herbicides. As many people are aware, pesticides and herbicides are incredibly dangerous to the human population. Pesticides and herbicides are used in modern-day farming techniques to remove pest infestations. Unfortunately, the chemicals are incredibly harmful to the environment and humans who come in contact with them. Almost 90% of the U.S. population has detectable concentrations of pesticide markers in their blood. Our project aims to help users who use pesticides and come in contact with them through runoff and purchased produce.
The reason that we are using UVB light is because it can damage the DNA of the weed. Plants, and by extension, weeds, use sunlight for photosynthesis for food, and because of that, they are unable to guard themselves from the UVB light exposure. For the design, we needed a solution that was harmless to the surrounding environment, cost-effective, reusable, and convenient. We also needed something that was mobile, but small enough to navigate through corn and wheat crop lines. We considered multiple different approaches with which to most efficiently utilize the UV light. Pictured to the left is a handheld design, a completely autonomous design, and a combination of the two which eventually became the design that we decided to build. The other two were scrapped for budgetary reasons.
Our final design for the chassis is made out of CNC aluminum pieces, which will be fastened together by 3 1/8 inch bolts. Here's one of the pieces here, one of the longer brackets, as you can see, and here's some of the holes where it's going to fasten together. Another piece is right here. This is one of the shorter brackets, which will help fit in there as well. And another piece here. This is the wheel bracket, which will let the wheels be fastened to the chassis. As you can see, the wheels will fit into this part right here. The 3 1/8 inch bolts will fit through here. Together, this is what they will all look like. Let's hide this. Okay, so here's the longer sections right here. And you can see they all fit together, and these are the mounting spots for the bolts to fasten everything together. Everything is mirrored, so there are 2 of the same parts that have been created. So this is the same as this over here, as well as this and this are the same. They're just mirrored versions of the same thing. Here's where the light cage will fit in, and this is the part that will fit the paracord, which will be able to raise and lower the light fixture to the ground and able to flash the ground with the light to kill the weeds.
My name's Harry, and I'm going to be going over with you our final prototype. Just so you know, we don't actually have all the parts. The chassis and the 3D pulley have not yet arrived yet, so we're just showing you the parts individually one by one. The first part, and the most important, and what gets our project going, is this. Of course, we'll be making this ourselves if we had the chance, but because of time constraints and because of health concerns, we decided to buy a UVB reptile light. And the bulbs inside you see here are just UVA, so they aren't as dangerous. Just know that in our final prototype, we'll be replacing this with UVB light bulbs. Next up, we have paracord, and this is for the, once again, the pulley. However, we don't have it, so I just wanted to show you guys what we have. Next up, we have reels. Again, this is not going on to the final prototype, or at least these types of reels. Timothy already explained before in SolidWorks when you guys looked at the 3D CAD stuff, but the wheels allow it to go back and forth onto ground. Again, the wheels are not fit for soil, but we just wanted to have wheels as a prototype and to show that it does work. And then we have the little ankle screws. Again, this is just for the chassis and stuff. It just isn't really have much to talk about. But yeah, now I'll be going back to you guys onto the field and I'll be showing you how my prototype works. Oh, didn't see you there. I'm just about to go and test the final prototype. Come on. Don't mind that. So, as Jordan once said earlier in the video, of course, UVB light is extremely dangerous, so we decided for UVA light bulbs you can see here. Again, this is just a prototype, so it won't affect the output too much. And I'm just gonna go ahead and plug it in. And yeah, we're gonna go ahead and use the UVA light on all of these. Alright. I can see it. Alright. So, this is how you use our prototype right here. You see, it now turns on. But we're gonna go ahead and just put it on top of this plant. Again, this would be more concentrated if we had our chances and stuff, but it's just an example. We're only turning on one light for safety as well. Go ahead and shine the light. And we're gonna go ahead and wait for about 10 seconds. Alright, now that 10 seconds has passed, the results you'll see will be in about 7 to 10 days when the weeds will be fine. This is because we're killing the plants from the inside using UVB light as Jordan said earlier. Yeah, this is our final prototype, and I'd like to thank you guys for watching.
Here are the projected results of our model in comparison to traditional pesticide-based weed removal system. In turn, it requires much less human labor and maintenance, especially while not in use, and doesn't rely on harmful chemicals, which are prone to infecting the crops as well as damaging the surrounding environment via chemical runoff. In terms of efficiency, the model only requires to be wheeled over a weed, the UV light to be lowered for 3 to 9 seconds, at which it can move on and the weed will die in the following 3 to 9 days. This allows it to be quite efficient and rival traditional pesticide methods in terms of covering large fields in quick amounts of time. The precision and the guards of the UV lights mean that it can target weeds effectively without damaging any crops around it. In terms of cost, it's much more financially viable in the long term due to the only upkeep being recharging the batteries after usage in comparison to traditional pesticides, which needs to be replenished constantly. Due to the simple design of the model, it can be used by anyone and requires little to no training, which means it can be utilized all over the world. Here are some alternative, more advanced concepts that we could have done given a higher budget or more advanced technology. First of all, more efficient power consumption. For example, solar panels could have been attached to the top of the model, which would have negated the need to return to a port to charge, as it could replenish its battery while it was out in the field, as well as more efficient LED lights that would take less energy. An automated predetermined path would allow for more automation in terms of AI. It could be also hooked up to a GPS that would give it a predetermined path that it could follow with little human interaction. Machine learning pattern recognition, a camera with pattern recognition that could identify and target weeds, which would remove the need for a human to operate it completely, as it would be completely autonomous while on the field, as well as airborne assistance in the form of drones and such, which would allow for on-the-field recharging or distribution and general convenience, which would allow for a much larger, more intricate system of robots for larger fields. In conclusion, because of the usage of UVB lights in opposition to traditional pesticides, our design is much less harmful to the environment and human health. And as previously stated, it is also much less, it's way more cost effective when taking into account the suffering chemicals cause to communities and individuals worldwide via crop contamination. If we were to do this project again with possibly more time and more resources, we would invest more research into the power consumption / quality of the lights, as stated beforehand, with possibly more efficient lights and solar panels, as well as a sensor system, i.e. the AI, for more automation. Thank you. And here are some references or sources. Thank you. Any questions?